Okay, today we're doing Math 3, Unit 1, Section 4, and we're talking about exponential functions. Exponential functions in the real world. Anybody have any examples that you can think of that you remember? Okay, so viruses usually are an exponential function. So do you guys remember last year when, what was the outbreak that was going on? Ebola? Okay. So it's like you had your patient 0, the first person that gets it, and then it just starts spreading. Like it's a rapid growth. So exponential functions, you see them a lot in science and those kind of things. Too bad it doesn't work this way like in your bank accounts. So exponential growth is something where it starts out like small and shoots up really fast, or the opposite way where it starts out big and then can decrease very rapidly. Very similar to all of our others is our shifting. So how does this shifting work? What do you guys think? When you add something to the graph, it's going to shift. Very good. Up is correct. When you subtract it from the function, it will go good. And then if you're adding it here, it's going to end up going left. And this one will go to the right. Anytime you have, bless you, negative of the function in front like that, it's going to what? Very good. Reflect off the x. Oops. And then this will reflect over the y-axis. Very good. Okay, so I want to kind of show you a couple examples before we go down here. And let's say that my function is y equals 2 to the x power. You may have seen something like this before, and we're taught that the easiest way to actually graph this would be to make a t-chart. Okay, so you have x, y. Normally you'd pick like the points 2, 1, 0, negative 1, negative 2 when you're graphing. And so when you plug, and the reason why I picked the values for x is because x is in my exponent. If y had been in my exponent, I would choose values for y. So when you plug those values in for x, sorry, what values do you end up getting? So 2 to the second power is 4. Yeah, I know that one was tough, huh? Okay. And 2 to the first power is, and 2 to the 0? No. 1. Anything to the 0 power is 1. Okay, and then when you go 2 to the negative first power, what ends up happening? You move it to the bottom and you end up getting a fraction. And so 2 to the negative first power will actually be 1/2. And 2 to the negative second power will actually be 1/4. Okay? And again, if you're like, I have no idea what you're talking about, 2 to the negative first power, anytime you have a negative exponent, you end up making it a fraction. Okay? Any number can be a fraction over 1. And anytime you have a negative exponent, it changes the side. So if it had been on the bottom, I'd move it to the top. Since it was on the top, I moved it to the bottom. And so you really have 2 to the first and the bottom, and 1 over 2 to the first is just 1/2. Okay? Do anybody have questions on that? Okay, so if I were to graph this, I would go right 2, up 1, 2, 3, 4. I'm going to make that a different color. Make my point. And then it goes right 1 and up 2. And then 0 up 1. And then negative 1 and we get 1/2, and negative 2 and I get 1/4. Now what ends up happening here is this exponential function, it gets closer and closer to 0 the more that it moves left, but it will actually never touch 0. And the reason is there is no value that I could end up putting into this for x that would give me an answer of 0. Because when I plugged in 0, I got 1. When I plug in negative numbers, I get fractions, and the fractions just keep getting smaller and smaller and smaller. Does that kind of make sense? Does anybody know what it's called when a graph won't touch a line? So it's called, and this is what we're going to go right here, it's called an asymptote. And oftentimes you'll see asymptotes as like dotted lines. And I always think of asymptotes like magnetic fields, where like, you know how you have two, if you had two magnets and you put them opposite together, they like push out a little bit. So you can't actually, let's pretend that you can't actually touch them. It won't ever stick together, right? But it could get really close to the magnet, but it never actually touches. And so that's like what this asymptote is. This line will get super duper close to the asymptote, but it never actually touches it or crosses it. Okay. Now, if I were to plug in, let's say, the value of 3 to the x. Okay. We're going to do just another example here to the side. Y equals 3 to the x. And I did a t-chart with x and y. And I'm going to do the same thing with 2, 1, 0, -1, -2. Oh, yeah. Okay, so when I plug in those values, 3 to the second power gives me 9. 3 to the first is 3. 3 to the 0, good. 3 to the -1, good. And 3 to the -2, good. Now, if you graph this, it actually looks very similar to this other graph. The only thing that's different is that, and we're just going to say this is 9 up here. Oops. Hopefully you can plot things better than me. Okay. The only thing that is different is that the larger the number here, the more quickly the graph accelerates. I think that's kind of, so larger number, we'll put like faster growth. Do you notice anything similar about the points from the y equals 2 to the second and the y equals 3 to the x? Or sorry, 2 to the x and 3 to the x. They're kind of equal. Look at the actual points. Do you see any similarities between the two graphs in terms of their points? Okay, good. They each have 0, 1. Okay, that is super important. Okay, and each exponential function, as long as it's not being shifted, you know how we can shift by adding or subtracting values? We'll always have the point 0, 1. Every exponential function has that point 0, 1. What do you notice from here? Like when it has the value 1 in it, it got the answer of 2. When it had 1 in here, it got the answer of 3, which makes sense, right? 2 to the first is 2. 3 to the first is 3. So if I had 5, 5 to the first would be 5. So whatever value is in your exponent, that value will also be 1 in whatever the base value is. Okay, does this so far make sense? Now, if you were to go and do t-charts for all of these, it would take you a long time, and it would be, you would end up getting fractions and not very fun numbers to work with. And so basically, I kind of am going to teach you a shortcut so that you don't have to do these big t-charts every time with the points for here. Are you guys ready to learn it? Okay. So since it's 2 to the x, I know that my original function with x and y, I would have the value of 0, 1 and 1, 2. Do we all agree? Because of the base 2, if it was my original function before it's being shifted, it would have 0, 1 and 1, 2. So we're going to make just 2 points on our graph. And what you have to do, the second thing I think you should do, is If the value's with the x, we know that we go right and left, but if it's at the end, we're shifting it either up or down. So if you're looking at this, y equals 2 to the x, which way is it going to end up shifting? Up 3, because it's not with the x. So I'm going to write here, up 3. Okay? Any confusion so far? So what happens is I'm going to go, where is 0, 1? Up 1 right here, right? So I'm going to go, because I know this point's on my original graph, which is at 0, 1. And then from there, I'm just going to go up 3. 1, 2, 3. And make my point. This point is at right 1, up 1, 2. But then from that, I need to go up 3. 1, 2, 3. Okay, so this, I know how my curve's going to be. The only thing is you have to remember, where is that asymptote? Well, on this one, my asymptote was at 0, right? So my asymptote's going to go up how many? 3. So I'm going to go up 1, 2, 3, and I'm going to go ahead and make this dotted line to remind myself, okay, that's my asymptote. It's going to get close to that line and then shoot up. Okay, do you guys want to ask me questions before we try another example? And I think the more you practice this, the better it'll get, but is that kind of clear? So we're taking like, what would be my function without shifts, and then I go to those points and I shift it from those points and then draw my graph. Okay? So again, when I go to this graph over here, my base would actually end up being like, my original function would be 2 to the x, right? Well, when I have 2 to the x without any shifting, when I plug in 0, I get a 1. And when I plug in a 1, I would get a 2. So these are going to be where my points start, and then I'm going to shift them. Now on this one, because it's with the x, which way am I going to shift? Right 1. And if you ever kind of forget, you can go back and look at what we wrote up here. But our shifts, remember, if it's with the x and it's adding, it's actually going to go left because we do the opposite. Okay, and if it's subtracting here, we go right. The only ones that are consistent are the ones that are kind of adding or subtracting at the end. So I'm going to go right how many? 1. Okay. So again, we start at 0, 1. So I go to 0, 1, and from there I'm going to go right 1 and make a point. I go to right 1, up 1, 2, and from there I'm going to go right 1. And if you wanted to, you could make your original points and then shift them and maybe do them in a different color. Yeah.
What are the remaining grades?
Oh, good. Let's go back to that. Thank you. Okay, so wait a second. I went right 1, up 2, and I didn't put this at the right point. Right 1, up 2, and then go right 1. Okay, and so would my asymptote have changed on this one? No, it's only going to change. Your asymptote's only changing if you're changing it up and down, right? So my asymptote is still at 0 because I didn't shift going up or down. And so then this is my exponential graph. Okay. Oh, go ahead. Okay.
And what did that little x like the teacher like? What did that do?
Which one? This one right here?
Yeah.
So this would be if my function was just 2 to the x power without having a -1 or whatever, that would be like the original function. Okay, and we talked about like 2 to the x power here, what it kind of looks like. And so basically what we're doing is we're going to take each of these as what they would be without having anything adding or subtracting to them, and then we'll shift them. And so basically my original function would really be 2 to the x, and so it'd be at 0, 1, and 1 up 2. And then, so it's like we have those original points, and then I know, okay, all I'm going to do is take this graph and shift it right 1. And then same with this one. I did my original 2 to the x function, and same thing, but this one I went and I just shifted it up 3. Okay? Now, going back to domain and range, what do you think your domain's going to be on this first one? Domain's dealing with your x values, and again, anytime you have these type of curves, your domain is really going to be all reals. So we're just going to do our r to take up less time. You guys understand that all reals is the same as negative infinity to positive, right? Okay. And your range. Now, remember how I said it's getting really close to something, but it's never actually touching it? Do you think we would use a bracket or a parenthesis? Parenthesis. Because a bracket is when it equals that number. You know, when we had a point at it, it equaled that number. Well, here it's going to get really, really close to 3, but it's never going to touch it. So we're going to use a parenthesis, and it's going to be 3 to positive infinity. So on the second one, again, we have our domain, which will be all reals. And what is my range going to be on this one? So your range is always like wherever your asymptote is, okay? And unless you shift it up or down, your asymptote will be at 0. So in this case, and it's going to be a parenthesis because it doesn't ever touch it, and then it'll go to positive infinity.
So is it kind of like the y intercept?
Yeah. Because your y will basically give you your smallest or largest value, but in this case, yeah. All right, you guys ready to move down to the next ones? Okay. So if we took off all of the shifting, this would actually just be a 3 to the x problem. Do we agree? And if we have 3 to the x, my original points would be when I plug in 0, I would get 1. And when I plug in 1, I would get 3. Would you guys prefer to make those points on the graph and then use a different color to actually shift? Okay, so we'll do that. So 0, 1, I'm going to make a point in blue, and then right 1 and up 1, 2, 3, I'll make that in blue. So that's my original graph, but we have all the shifting that's going on here. So with the x, if it's adding 2, that means I'm going to shift it which way?
Left 2.
Very good. Left 2 is correct. So we're going to go left 2, and then when it's subtracting 1 at the end, I'm going to go down 1. So right now, I'm going to take each of these points. I'm going to go left 2, down 1. So we're going to go left 1, 2, down 1, and make a point. Okay, from this point, I'm going to go left 1, 2, down 1, make a point. So that's my actual graph in red. Okay, now since I went down 1, where is my asymptote going to be? Good. So I'm going to go ahead and make this dotted line to remind myself that the graph does not cross that. It also kind of helps me when I'm writing my range. Okay, and so my domain is going to be what? All reals. And my range is going to be? Good. Perfect. That's it. -1, positive infinity, both in parentheses. Are you guys ready to try the next one on your own? Okay, so I want you guys to try this one on your own.
So it's basically whatever you think this is, and then you know this is because we get the first column is and then the next two is 1 and 2. So if it was 5, then you have 5. Okay. And then also do you understand that whenever you shift whatever this value is, that ends up keeping your asymptote in your which means that when you're doing your range, you the asymptote's going to get to it. So you're not going to have to one.
Oh.
You're going and then when you're running the range, your range is like that.
Okay.
Does that kind of make sense?
Yeah.
So what I understand is the range is going to be and then anything that's an opposite is the opposite. And so since it's a one, so I'm just going to do it exactly as you so you're going to say a little bit of the opposite. So x is going to be and so this means you're going to so if there's a difference in the and that's what it's going to be. So this one is right. I mean, not right way. So that's where you're like the original is that 0,000. Now you're going to shift this one, right one, up two. So each of these points are going to shift that.
Okay. I think most of us got it. Please stop me if you guys have questions. I want to answer them. So this graph, our original graph would be 3 to the x. For x and y, if I plug in 0, I get 1. If I plug in 1, I get 3. Remember that you're going to get 1 in whatever this number is, because if 1 was in here, 3 to the first is 3. So 0, 1, right 1 up, 1, 2, 3. Okay? Now shifting. This is shifting. It says x there. That should remind you that you're going to go right and left that value. Because on the x-axis, x is right and left, correct? And so, therefore, if you were to go x minus 1 equals 0 and you would get x by itself, you would end up getting x equals 1. So this is why we're just going to always do the opposite, because we can think about it that in our head that it's the opposite. But positive 1 means right 1. Because right is positive, left is negative. So we have to go right 1 and then up 2. This is our y value at the end, your up and down. So from this point right now, I go right 1, up 1, 2, make my point. This had a red point, and I'm going to go right 1, up 1, 2. Okay? Now, my asymptote was originally at 0, but again, that's also going up 1, 2. So this is my asymptote now, and my curve goes just like this. So what would my domain be? Good. And my range is going to be? Good. 2, positive infinity. Questions before we move on? No? All right. Okay, so here we're going to write exponential functions for the given examples. Now, I think I did this more difficult in my notes. Okay. So first of all, we know that on every graph, no matter what it is, you have an original shift or original point of 0, 1. Do we agree? Okay. And so if you were at 0, 1, what happened in order to get it down to this?
Down 3. Right,
Down
down 2.
2. So from 0, 1, if you go down 1, 2, that's at negative 1. So I know for sure if I were writing this, and I'm going to put y equals, and it's going to be some number. I'm going to put b to the x, and we know we're going to have to subtract 2. Okay, so far so good? Okay. I think, and again, if you think of a different way, please share, okay? Because I'm not all-knowing. I know it's surprising, but this ordered pair right here, what is this? Okay, so we have the ordered pair 1, 2. Remember that these go x and y. I think we should plug these values in and find what our base value should be. Okay, so what do I mean? I'm going to plug in 2 for y equals b to the first power minus 2. Then what will I do to get b by itself? Add 2 to both sides, and these cancel, and I get 4 equals b. Yeah? And so that means that my equation is, so now I'm just going to take this value, it's the same equation, and I'm just plugging that in for my base. So that means my equation is y equals what?
4x power minus 2.
Good. 40x power minus 2 is correct. Okay? Are you guys ready to try another one? We'll just do it together though. Okay, so again, you know, with our x and y, we know for sure we start with a point at 0, 1. So if I go to 0, 1 here, this has been shifted. And so it has been shifted 1, 2, 3, 4, up 1. So that is right 4, up 1 is my shift. Does everybody agree?
Yes.
Okay, so we start at our bottom point, we get to our bottom point. Okay? When we're writing the equation, we know it would end up being y equals some base value to the x, and then what should I put with the x? We know the right and left has to deal with the x. Would it be plus 4 or minus 4? Very good. And then what would go at the end? Very good, plus 1. Okay, so next we need to pick another point to plug it in and find out what our base value is. Okay, so what is this other point right here? Okay, so we have the point, and we can even write it on here, 5, 3. Okay, or maybe it's not really there, but. So if I were to go in here, I am going to write 3 equals b to the 5 minus 4 plus 1. What is 5 minus 4? 1. Okay, which works out very nice because I just have b to the first power. I subtract 1 to both sides, and what is 3 minus 1? 2. So 2 equals b. So now we can write our equation. And how will I write it?
Y equals 2. X minus 4 plus 1.
That's it. Y equals 2 to the x minus 4 plus 1. And that's our function. Instead of writing y, I could also write f of x, right? Either way. Okay, do we have questions here? Okay, so now they're asked us to graph these and graph the function and its transformation, and then describe the transformation. Okay, so this one would originally be at what? Without the shifts, it's going to be at 3 to the x, which means that my 2 points for x and y would be where? 0 and 1, and 1 and 3. Okay, and then how am I going to shift this one? Before I do this part, how would I shift here? What am I going to do? Good, down 2. So let's go ahead and mark these original points, 0, 1, and if you don't do the original ones, that's fine. And then from there, I have to go down 2, right? So if it were 3 to the x, this is where my points would be, that it's not 3 to the x, it's 3 to the x minus 2, right? And so I take this and go down 1, 2, down 1, 2. And where's my asymptote? Good, -2. So I'm just going to kind of mark that. So we have this graph. Okay, now what is going to happen when we go negative f of x? Reflex over the x. So what will I do? From each of these points, since this is 1 away from the x, I have to go 1 away from the x, right? And this way, this is 1 away from the x, and I have to go 1 away from the x. Where do you think my asymptote would be for a reflection across the x? A +2, good. And so my red graph and my green graph are kind of opposites, right, of each other, and it looks like that. And we would state that it reflected across the x-axis. Do we have questions about this one? Gabby, are you good?
Yeah.
Okay. Are you guys ready for number 8? Okay. So without doing any shifts or anything on my original h of x, that would be a 2 to the x, correct? And 2 to the x has the points 0, 1, and 1, 3. Yes? Okay. Now, how is this going to end up shifting? That one right there.
Down 4.
Okay. Down 4. And then what about the other part? Good. Left 3.
Why is it 1, 3?
Great question. It should be 1, 2. You just earned yourself a candy. Way to go. All right. So 0 up 1. And right 1 up 1, 2. I totally did it on purpose just because I wanted to give out candy. Just kidding. Okay, so where do I go now? Good, left 3. So I'm going to do each of these points. Left 1, 2, 3. Down 1, 2, 3, 4. Here's my point. Okay, and then this one. Left 1, 2, 3. Down 1, 2, 3, 4. And where is my asymptote going to be at? What's it going to be at? -4, because I went down 4, right? So it shifts with that. Okay, so we draw our exponential function. So that's our first one. Now, this one's actually pretty easy because now they're just telling us we'll do h of x plus 3 plus 1. So on this shift, where am I going to go? Good. Left 3. And then what? Up 1. Left 3, up 1. So I'm going to just take this point right here and I'm going to go left 1, 2, 3, up 1. This point, same thing. Left 1, 2, 3, up 1. And that's the other function. Now, to figure out what actually happened, the translation, you have to pick just one of your points and do the same point on each of them. So this one is translating. So what happened? What happened where it went from blue to green? Good. So it went left 3, 1, 2, 3. So left 3 is -3. And then what? Up 1. So that's a +1. And if you want to write left 3, up 1, that also works. Okay? Questions? Do you think you're ready to try one on your own? Who thinks they can do it? Give me a thumbs up if you think you can do a translation on your own. How many are like, no way, do one more at least with me? Okay. So let's do this one together, and then I want you to try this one on your own. Or we can do opposite. I don't think either one's harder. I don't know. Okay, let's just do this one. Here we go. Are you ready? So we can see both of these are 2 to the x. So for my original function, if there was no shifting, for 2 to the x, we would have a 0 and a 1, and we'd have a 1 and a 2. on this first one right here, how will I shift it? Left 4. Okay, remember that if you ever forget, look in your notes, okay? And we talk about how these shifts work. So whenever it is with the X, it's going left and right. Okay, so going back here. We have a point at 0, 1, and I have a point at 1 up 2. So I'm now going to take those points and I'm going to go left 4. Okay, so this one I'm going to go left 1, 2, 3, 4. And this one 1, 2, 3, 4. Where's my asymptote at? 0. And so if you want to, for each of the lines, if you want to do them a different color so you can kind of see the difference, it's at 0 for there. Okay, now g of x, and you're supposed to label, so that was my f of x graph. For my g of x graph, I'm going to use a different color. I'm going to use green. It has the same original function that we start at, and then how is this one shifting?
Up 4.
Very good. So this one's going up 4. So I'm going to start at these same original points, and then I'm going to go up 1, 2, 3, 4. Up 1, 2, 3, 4. Bless you. And where would my asymptote be on this graph? Good. Positive 4. Wait. Yeah. Okay, and that's where my graph would be, and we would label that g of x. And then you need to state, well, how did it transform? What happened with the translation? You need to remember which one you started with. So I started with red, correct? And so in order to get from red to green, it went how many? How did it translate? It went right, 1, 2, 3, 4. So right and left is 4. And then it also went up 4. So it went right 4 and up 4. Okay. I want you guys to do this one on your own, but I feel like we are running out of time. So therefore, you lucked out, and we're going to do it together. Okay. So this one, our original function would be 3 to the x power. What would be my 2 original points for 3 to the x power? 0, 1, and 1, 3 are correct. So we go 0 up 1, and then right 1 up 1, 2, 3. So those are my starting. F of x now I'm going to do in red. Okay? So, yes?
Oh, okay, I see. Never mind. I'm stupid.
No, you're fine. Okay, how am I going to shift my f of x function? Left 1 and down 3. Good. Okay, so from this point, we're going to go left 1, down 1, 2, 3. Okay, from this point, left 1, down 1, 2, 3. Where is my asymptote at? Good. So I'm just going to kind of draw that to remind myself that this graph does not cross it. And we have that one. So that is f of x, and again, we should label that f of x. Okay, now we go to g of x. I'm going to do this one in green. And this one, same original function, and how is this one shifting? Good, right 4, and good, down 1. So from this point, I'm going to go right 1, 2, 3, 4, down 1. From this point, right 1, 2, 3, 4, down 1. And where would my asymptote be on this one? -1, very good. So we draw our graph. Okay, and so how did this one shift? So I'm going to go to my bottom points on each of them. Okay, so from here it went right 1, 2, 3, 4, 5. So translating right 5 and then up 2. Right 5 up 2. And that's my answer.
If you just go from like the f of x to the original point, or
No, f of x to the g of x. So like my original points are really just helping me plot my graphs. Any other questions?